Example: main oil line pump with variable speed drive, VSD. A main oil line pump, MOL pump, with a variable speed drive, VSD, is typically used in pipelines to adjust the flow rate according to the demand and maintain operational efficiency. Below is an overview of the inputs, outputs, control, monitoring, and shutdown mechanisms used in the operation of such a pump. 1. Process inputs. Inlet pressure from the upstream pipeline section, pressure transmitter. Outlet pressure to the downstream pipeline, pressure transmitter. Flow rate through the pipeline, flow meter. Fluid temperature, temperature sensor at the inlet. Viscosity measurement for crude oil applications, viscosity analyzer. 2. Electrical and motor inputs, motor voltage and current feedback. Motor speed, tachometer or encoder signal. Power consumption from power analyzer. 3. Environmental and auxiliary system inputs, bearing oil pressure and temperature. Pump casing temperature, pump shaft vibration levels, vibration sensors, differential pressure across the pump strainer. Outputs. 1. Control outputs. VSD control signal to adjust motor speed, analog or digital signal. Control signal to the pump discharge valve to throttle or open as required. Signal to auxiliary systems, cooling fans, oil pumps, etc. 2. Alarms and indications, local and remote display of flow, pressure, temperature, and motor speed. Status indications for normal operation, trip or standby mode. Operator notifications for early warnings, e.g. low lubrication oil pressure. 3. Trip signals, motor stop command in case of emergency to motor breaker. Shutdown of auxiliary systems, e.g. oil cooling if needed after pump shutdown. Control functions. 1. Speed control. The VSD regulates the speed of the pump motor to maintain the set flow rate or pressure. PID controllers adjust the VSD output based on feedback from flow and pressure sensors. 2. Flow and pressure control. The pump speed is adjusted in real time to ensure the pipeline pressure does not exceed safe limits. If high pressure is detected at the discharge, the speed is reduced, or the discharge valve modulates to relieve excess pressure. 3. Pump startup sequence. The control system ensures a smooth startup by ramping up the speed gradually to prevent water hammer and pressure surges. Pre-start checks for lubrication pressure and strainer differential pressure are validated. Monitoring. 1. Local monitoring. Instrumentation at the pump site provides real-time information on pressure, flow, temperature, and vibration through local displays and HMIs. 2. Remote monitoring. A SCADA or DCS system provides centralized visibility of pump performance and health. Trend analysis tools in the SCADA DCS track historical data for predictive maintenance. 3. Alarms and status monitoring. Early warning alarms for increasing vibration levels or rising temperatures. Status indicators for operational modes, running, stopped, fault. 1. Automatic trips. High discharge pressure trip if pressure exceeds set point. Low suction pressure trip to avoid cavitation. High bearing or motor winding temperature trip. High differential pressure across the pump strainer, indicating blockage. High vibration trip, indicating imbalance or mechanical fault. 2. Emergency shutdown, ESD, activated manually from a local or remote emergency stop station. The ESD sequence immediately stops the pump and isolates the flow by closing relevant valves. 3. Controlled shutdown. When a shutdown is initiated, non-emergency, the pump speed is reduced gradually to prevent sudden flow stoppage and pressure surges. The cooling and lubrication systems remain operational during the cool-down period. Safety and environmental controls. Gas detection systems near the pump to detect flammable vapor leaks. Oil sump level monitors to detect leaks in the lubrication system. Pressure relief valves and interlocks to prevent excessive pressure buildup. This configuration ensures that the main oil line pump operates efficiently, safely, and reliably, adapting to changing conditions while preventing damage to equipment and minimizing downtime in case of failure.